Okay, the first flow controls instruction or flow control that you're going to learn is a if statement. Okay, what is if statement? If statement, okay, check a condition. And if the condition is true, okay, it will branch to the specific code section. Okay, so this is the what we call here the flow chart of if statement. Okay, we can see here. This is where you're going to put the if statement lah. Okay, let's say I put x greater, is it x greater than 0? If yes, okay, what happened? If no, it will go to end. So this is the if statement. Okay, it only have one code section to execute. Okay, that is it when the condition if true. If the condition is not true, then it will go to end the programs. Okay, and here you can see we have uh, two programs here. Okay, one is using the C programming. The second one using the assembly language. Okay, the ARM assembly language. Okay, looking at the C programming. Okay, what this C programming do? Okay, first, x equal to 10. Okay, means that, okay, now you initialize your x so that your x equal to 10. And then after that, you have the if x greater than 0. Okay, you're going to check whether the x is greater than 0 or not. If the x is greater than 0, then x equal to x minus 1. Okay, so this is when the condition if. What happens when the condition is false? Okay, when the condition is false, which is x is smaller than 0, so it will exit from the statement. Okay, go to end. So this is when the statement is false. Okay, now we're going to write a assembly language. Okay, so to write an assembly language, okay, so my advice to you is, okay, always draw the flowchart. Okay, so that you not miss anything when you write the assembly language. Okay, so every time you're going to do a flow control, make sure you draw the flowchart. Okay, so now based on the C programming, we're going to write the assembly language. Okay, so I just draw the flowchart here. Okay, from the flowchart, we initialize x equal to 10. Okay, so this is where you're going to start lah. Okay, so initialize x equal to 10. Then after that, we have the if else statement here. Okay, if x equal to greater than 0. So this is where you put lah. Is it x greater than 0? If yes, then you have y and no. Okay, so you just put y and no. What happens when x greater than 0? When x greater than 0, then x sama dengan x minus 1. So this is the code, the statement that you're going to execute whenever the x is greater than 0. If not, okay, if not, just go to end. Okay, so we already have the, what we call here, we already have the, sorry, we have already have the flowchart. Okay, now we're going to identify what instruction that we're going to use. Okay, every time we do the condition, to check the conditions. Okay, based on this one here, okay, we saying that greater. Okay, x must greater than 0. Okay, so we go back to the table earlier, find the condition that is greater than 0. Okay, So this is the first condition, greater. This is greater. Okay, so you have two instructions for the greater. One is high, and the other one is GT. Okay, and this is depend on the numbers lah. If the number is a signed number, then we need to use the GT. Okay, if the number is a unsigned number, then you can use the high. So we have high and GT. So this is for the greater lah. Okay, what happens if the number is less or equal than 0? So you can use the LS or LE. Okay, here. Okay, now we already identified. Okay, what is the condition code that we're going to use? Okay, moving back to this one here. Okay, to the flow chart. Okay, now we have a flow chart. Okay, if greater than, so just now is high or GT. Betul ke tak? Okay, according to this one here, we already identify. Okay, if high greater than high or GT. Is smaller or equal LS or LE. Okay, so this one is LS or LE. Okay, and we assume lah. Okay, this number is a signed number. Okay, when signed number, okay, we need to use the LE for smaller and GT for greater than. Okay, so we assume this is a signed number. Okay, so signed number, we're going to use the GT for greater than and LE for smaller or equal. Okay, so now you already identify the instruction that you're going to use. Okay, so now we're going to write the program lah. Okay, so in this case we have two solutions. Okay, either you're going to choose the yes or you're going to choose the no. Okay, there are two solutions here. Okay, I just show you both solutions. Okay, so before that, okay, we need to initialize lah, because we have the x. Okay, we need to initialize. Okay, the variable x is, okay, you're going to assign lah your register for this variable x. Okay, what register that you're going to use for register x? Okay, assume that, I assume, okay, R1 is my x. Okay, so I just assume R1 is my x. So now I'm going to write the programs. Okay, the first, so look at this here. Okay, this is the first step lah. Okay, which is x equal to 10. So how to make x equal to 10? So move, by using the move instruction, move R1 with what value? Hashtag 10. So here R1 sama dengan 10. Okay, or x sama dengan 10. Okay, next, what I'm going to do? Okay, by looking at this flow chart, now I'm going to compare. Okay, going to compare x with 0. So by using the CMP instruction, okay, x is R1 and compare with 0. Okay, so my second operand is what we call here immediate number. So now I'm going to compare lah. R1, my x is 0. Okay, So here I'm going to choose yes. Okay, so yes, I'm going to choose yes. Okay, if x greater than 0, so I'm going to choose yes. So I use the BGT. Okay, if my R1 is greater than 0, so it will go besar lah. Okay, I just put a label besar. Okay, where is a besar? So I put the label besar down here. Okay, so when it's a besar, what happened? When yes, besar. Okay, so next I need to x equal to x minus 1. Okay, so how to make x equal to x minus 1? Okay, we can use the SUB instruction. Sub R0, sorry, not R0, R1. R1, because R1 is x, R1 minus with 1. So this is what happened. Okay. This is x equal to x minus 1. So this is when besar lah. Okay. And when after I finish besar, then it will go to n lah. Okay, so n, we just use the NOP instruction for n. Okay, I just put the NOP there. Okay, for n. So now my program ends here lah. So this is where my program ends. Do nothings. NOP is a stand for no operations. Do nothing. And what happened if my x is small than 0? Okay, when the x is small than 0, so I need to put the B kecil. Why I need to put a B kecil? Because if my x is smaller than 0, which is a no lah. This is when the case is no. I need to go to n. Okay, so when x smaller than 0, okay, my flow must go to n. Where is my n? At this NOP. So here I put the kecil. Okay, kecil NOP. So this is where x smaller than 0, it will jump to this n. And when the x greater than 0, it will go to this besar. Okay. Can you follow? This is by using the BGT. Okay, so for the BGT, you need to have a few lines lah. Okay, in order to make a complete program. Okay, let's say I choose the LE. Okay, now I'm going to choose the LE, not the BGT. So what would my program looks like? Okay, so first, again, okay, we need to make sure that x equal to 10. So how to make x equal to 10? Okay, so I just copy this one here. Okay, never mind. I thought I can copy all those things, all those, what do you call it? Project. All right, so now if I'm going to choose the LE, okay, previously we using the BGT. Okay, now we're going to use the BLT. Okay, for the BLE, okay, same things lah. Okay, so what you need to do is, okay, first we need to initialize x equal to 10. Okay, so MOV R1 hashtag 10. Okay, after you initialize, then after that, we're going to compare. Okay, compare with what value? Compare with 0. So CMP P R1 hashtag 0. So this way you're going to compare lah. Okay. Then now we're using the BLE. Okay, BLE. Okay, what happened when BLE? Okay, its value is smaller, then it will go directly to N lah. Okay, dia akan pergi N. So here I just put the kecil lah. Okay, kecil because the value is smaller, and I put kecil down here. Kecil. Okay, no operations. Okay, so this is where the programs end. Okay, so this is where the X smaller or equal 0, it will go to kecil. So what happens when my X is greater than 0? Okay, when my X is greater than 0, so what I need to do? I need to do this operation X equal to X minus 1. So up R1, R1 hashtag 1. So this is where X sama dengan X minus 1. Okay, then after you finish X minus X, X equal to X minus 1, then it will go to N. Okay, so we already have the N down here. So this is the program. Okay, if you can see here, by choosing the LE, okay, branch less equal, okay, the total instructions, okay, needed is only 1, 2, 3, 4, 5 instructions. This is by using the BLE. But, okay, if you're using the BGT, okay, you need to have 1, 2, 3, 4, 5, and 6 instructions. Okay, so this is BGT. Okay, both solutions are correct. Only that, okay, BLE, small instruction, okay, small size of an instruction. Okay, you have a less instruction compared to BGT, which is you have a more instruction. When you have a more instruction, what happened to when you have a more instruction, what happened to your program space? Okay, you use more program space to store the programs. Okay, Najmi asked here, okay, can we get slide note after the class? Okay, the slide note I already put in the, what we call here, in my website. Okay, if you go to my website, okay, earlier, that I show you earlier, where is the website? Okay, so this is the website. Okay, you can see here, this is the lecture notes. Okay, inside of here, I already upload, okay, when you click that one, okay, you can see here, I already upload up to module 9. Okay, so you just can download from my website. Okay, any question from you? Okay, before we go to the if-else statement. Ada soalan tak? So this is only for the if statement, okay, which is you only have one condition. When the condition is true, then you have the program that you need to execute. If the condition is false, then you exit from the statement. Any question from you guys? Okay, if no question, okay, then we move on to these examples. Okay, we have a few examples here to do. Okay, the first example. Okay, we see if A equal to, okay, the left hand side here, this one is in C program, yeah, and this one is in assembly. Okay, so here it says that A equal to 5. Okay, if A equal to 5, okay, we just draw the what we call here flow chart. Okay, is it A sama dengan 5? Yes, no. Okay, if yes, then after that, okay, you need to do a B equal to 3. Then go to N. If no, okay, directly go to N. So this is your. Okay. So now we are already draw the what we call here the flowchart. Okay. And we're going to identify what instruction that we're going to use. Okay. So can you tell me what instruction that you're going to use? Is it greater than, less than, equal, not equal? Can you tell me what instruction that we're going to use here? Okay, because you see, can see here from this if else statement is saying that is it A equal 5. Okay, so we need to use the equal lah. Okay, so equal. So equal is here. So we have two instruction lah to choose from. One is branch not equal, and satu lagi is a branch equal. Okay, now you're going to identify. Branch equal is for what? Branch not equal is for yes or no? Okay, branch equal. Branch equal is for yes lah. Because if A equal to 5, then yes, B sama dengan 3. If not, it will go N. Okay, and the second one here, branch not equal. Okay, if A not equal 5, yes, A is not equal 5, then it will go to N. What happens is A equal to 5, it will go, okay, perform P equal to P. Okay, so we already identify, okay, the instruction that you're going to use. Okay, now we are going to write the program. Okay, so I just show you two solutions lah. Okay, the first one by using the BNE. Okay, so this is a BNE. The second one by using the BEQ. Okay, so what you need to do? Okay, before we write the programs. Okay, we need to assign lah. Okay, the register for variable A. Okay, so assume lah R2 is A and R3 is B. Okay, you just assign yourself. Okay, put the assumption here. R2 is A, R3 is B. Okay, on the start here, on the start of the program, do you need to initialize your R2 and R3 value? No need. So tak? Okay, based on the program from this C program, okay, no need to initialize your A and B. Okay, so we just start with the if statement. Okay, so by using the compare CMP, okay, A is R2. Okay, you're going to compare with what number? Number 5 lah. Okay, so now we're going to compare with number 5. Is it A equal to 5? Okay, we just compare with 5. Okay, branch not equal. Okay, when branch not equal, we're using this branch not equal, what happened? Because the 5 is not equal to, because R2 is not equal to 5, the A is not equal to 5, and it will go exit. Okay, so you just put the tamat. Where I'm going to put the tamat? Okay, I'm going to put down here lah, tamat. Okay, so do nothing. And OP. Okay, next. If A equal to 5, what happens when my A is equal to 5? Okay, so when A equal to 5, so B sama dengan 3. I need to make sure that, okay, I need to assign B is 3. So how to make my B is 3? By using the MOV, okay, R3, hashtag 3. Okay, so here, you can see, okay, so this is where B sama dengan 3. Okay, so here when A not equal to 5, it will go tamat. But if A equal to 5, it will do this MOV instruction. Then after that, it will go N. So we already have an N down here. So that is our program. So we have only 1, 2, 3, 4 instructions. By either B and A. Okay, next, BEQ. Okay, BEQ. By using a BEQ, how to do it? Again, compare lah. Okay, CMPR2, which is our A, with 5. Okay, and then using the BEQ, branch equal. Okay, branch equal means that, okay, we're going to do this thing lah. Okay, bila equal to 5, okay, we think that, okay, sama is equal. Sama. Where I'm going to put a sama? Down here lah. Sama. And what happened when sama? Okay, B equal to 3. Okay, so MOV R3 hashtag 3. So this is where B sama dengan 3. Okay, so this one here, this is where A sama dengan 5. Okay, it will jump to sama. Okay, then after that, after I finish the assign R3 with 3, it will go N lah. So down here, I need to put N of P lah. So N of my programs. Okay, so this part I already did. What happened if A not equal to 5? Okay, when A not equal to 5, okay, I need to lompat lah to the N. Okay, so branch, using the branch. Okay, because we using the branch, tamat. Where I going to put the tamat? Okay, so I need to put here. Don't put here. If you put tamat here, what happen? Okay, it will jump here. Then after that, the CPU will execute move number 3 to R3, which is wrong. Okay, but why? Because the CPU will execute from top to bottom. Okay, since the tamat you put here, and there is a instruction down the tamat, so the CPU will still execute this line. Okay, so you need to make sure lah, you put the tamat at the proper location. Okay, where you going to put the tamat? Here we're going to put the tamat kat sini, down here, so that this instruction will not execute. Okay, if A not equal to 5. Any question from you guys? We still in if statement. Okay, so now we're going to look at the second example. Okay, the second example says that, is it A equal to B? Okay, we just draw lah. Okay, draw the flowchart. A equal to B, then you have a yes, no. Okay, so what happened? If yes, C sama dengan C divided by 2. C equals C divided by 2. Okay, then after that, N. No, go to N. So this is the flowchart. Okay, so now what instruction that we're going to use? Okay, so we need to check lah what condition that we're going to look at. Okay, since this one here, it says that equal. Is it A equal to B? Okay, so equal, you can use the BEQ. And the other one is a B and E. So this is a BEQ lah. So when equal, this is BEQ. And this is B and E. Okay, again, we have two solutions. One by using the BEQ, and the second one by using the B and E instructions. Okay, so before you write down your program, make sure that every variable you assign to your register. So let's say lah, R0 is A, R1 is B, and R2 is C. Okay, do you need to initialize your A, B, and C? No need. Okay, so just we go directly to the if statement here. Okay, you did the compare. So CMP R0 with R1. Okay, you're going to compare. Compare A and B. Okay, now we choose the BEQ dulu lah. BEQ. Okay, BEQ is a sama lah. Okay, if both R0 and R1 sama, so we put the sama down here. Okay, what happened when sama? Okay, when sama, C sama dengan C equal to C divided by 2. Okay, what instruction that you're going to use here? For C equal to C divided by 2. Okay, for the divided by 2, you can use the div instruction, or you can use this instruction, ASR. Okay, we can use for dividing by 2. Okay, dividing by 2, we can use the ASR instruction or LSR instruction. Okay, logical shift right or ASR instruction. So ASR for the signed numbers lah. LSR for unsigned number. Okay, if you have an unsigned number, let's say like this, we assume that this is a signed number. So we using the ASR. Okay, so ASR, what value? C. C is R2 lah. Okay, and then how many times that you're going to shift to the right? One time. Okay, so you put R2 hashtag 1 because you divided by 2 only. If you divided by 4, then after that hashtag 2. Okay, the number of bit that you're going to shift it will determine how many what is the value that you're going to divide. Okay, if you're going to divide by 8, then you need to shift to the right how many times? 3 times. Okay, so when you finish, okay, divide by 2, so this is equal to C sama dengan C divide by 2. Once you finish, then it go to end lah. So I just put NOP here. Okay, sometimes, okay, we can put this one. Instead of using the NOP, you can put the branch, tamat, and tamat. Okay, means that it will keep branching at this location. Okay, once finished, it will only branch at this location. Okay, this by using the BEQ when the A equal to B. Okay, so when A equal to B, yeah. So A equal B. If not equal, what happened? Okay, if not equal, okay, according to this flow chart, okay, we need to go ends. So what you need to do? Branch tamat. Okay, because our end is at tamat, so it will go down here. Okay, so this is by using the BEQ. Okay, if you decided, okay, I'm going to use a BNE. I don't want to use a BEQ. I'm going to use a BNE. So again, compare R0 with R1. Okay, you're going to compare. Is it A equal to B? Okay, now A is not equal to B. Okay, so you just put tamat. Okay, so where you going to put tamat here lah? Okay, tamat, branch, tamat. Okay, it will keep repeating there. Okay, this is A not equal B. Okay, what happen when A equal to B? Okay, when the A equal to B, then I need to divide C by 2. So A is R2, R2 hashtag 1. Okay, once I finish divided by 2, then it will go and okay, so directly go to N. So again, you can see here for B and E, I'm only using 4 instructions, but by using the BEQ, okay, I'm using 5 instructions. Okay, any question from you guys? Okay, before we move to this if-else statement. Else statement, go control. Any question from you?
Okay.
Okay, if no question, then we move on to the if-else statement. So if-else statement branch to one block if a condition is true, and another block if the condition is false. Okay, so means that you have two conditions or two blocks. One condition, one block for true conditions, and the second block is for false condition. And this is the flowchart. Okay, so we just do a comparison here. Do the if else. If yes, no. Okay, so there is a conditions. Okay, when a condition is true, so you need to run a block for true. And when the condition is false, then you need to run a code for false condition. Then after that, it will end that. Okay, let's look at this contour. Okay, we look at this C programmings. Okay, if A equal to, if A greater than B. Okay, so here we just write down, is it A greater than B? Yes, no. Okay, so when A greater than B, then what happen? Max sama dengan A. Else, if A is smaller than B, then max equal to B. Then after that, it end the program. Okay. So in this case, okay, what instruction that you're going to use? Okay, again, we have this instruction. Okay, greater, smaller, or less or same. Okay, greater and less and same. Okay, so we need to choose lah. Okay, which instruction? Okay, we have this one here. Okay, we already derived earlier. Okay, BHI or JT for greater, LS or LE for smaller or equal. Okay, so assume that we if the number is unsigned number, then you can use a high and LS. If it's signed number, then you use the GT and LE. Okay, we assume D is a unsigned number. Okay, so unsigned number, we use the HI and LS. So D is HI and D is LS. Okay, so high is here, LS is here. Okay, now we're going to write a program. Okay, before we write a program, okay, I just copy back. Okay, greater than B. Yes. No. Max sama dengan A. And this one is max equal to B. And then it will go N. Okay. So this is HS and sorry, HI. And this is LS. Okay. So now we're going to write the programs. Okay, so you have how many variables here? You have 3 variables. One is A. So R1 is A. R2 we assign to B. And R4 is max. Okay, you just put assumptions. Okay, R1 A. Register 2 is for B. And R4 is a variable max. Okay, now we have 2 solutions here. One by using the HI and the second one by using the LS. Okay, so what you need to do? Okay, no initialization needed. So you just compare lah. So CMP R1 with R2. Okay, we're going to compare A with B. Okay, and then use the BHI. Okay, BHI means that besar. I put a besar. Besar is a greater lah. Means that R1 is greater than R2. Okay, so when I want to put a besar, I just put down here lah. So this is a besar. So what happened when besar? Okay, so the maximum is actually my A. Okay, the maximum value is my R1. So what instruction here? MOV lah. Move R4 with R1. Okay, so now we can see here. You can see. Okay, we move its value here, A to max. Okay, so that's why move R4, R1. Why? Because R4 is my max and R1 is A. So whatever value from A, I put it inside of R4. And one finish, then after that, it will go N lah. So just put tamat here. Tamat, branch, tamat. Okay, this is where your program ends. Okay, I just put here. It is where A greater than B. Okay, what happens when A is smaller than B? Okay, when your A is smaller than B, so you need to assign maximum is the B. Okay, maximum is coming from B lah. So use the MOV instruction. R4, R2. So this is where maximum sama dengan B. And this is maximum sama dengan A. Okay, then after I put the maximum equal to B, then I need to go to N, tamat. Okay, so what you need to do? Okay, if I leave like this, what happen? It will do the move R4 to with R1, which is wrong lah. So I need to branch to tamat. So I need to put a B instruction here and tamat. Okay, so after finish, then it will go to this tamat. So this is my program using the BHI. Okay, we assume this is an unsigned number. And then next, we using the LS lah. Lower S equal. Okay, so again, compare lah. Compare R1 with R2 and BLS. Okay, so this one here, A is smaller lah. So I using the kecil. Kecil is for the smaller. And kecil I put down here. Okay, when kecil, what happened? When my A is smaller than B, okay, so I need to assign lah. Maximum is coming from B. So my B is R2. Okay, so when A is kecil, smaller than R2, so the maximum is coming from R2. Max is equal to B. And then after that, okay, after that, it will go to tamat ends and the programs. Okay, so tamat, branch, tamat. Okay, so this is if the case is smaller than B. What happens if A is greater than B? Okay, when A is greater than B, so this instruction, okay, is not met. The condition of this instruction is not met. So I need to put a move R for R1. So this is where max permanent A. Then after finish, okay, I need to jump to tamat. Okay, so this is the instruction. Okay, any question from you guys?